us see how this SR lux circuit will work, right? You know, like we can able to give the two input values for S and R, like it can be a 0 0, 0 1, 1 0 or 1 1. What about Qn input? Qn input, if you would like to give, it is going to be depend on Qn bar, and if you would like to give the Qn bar, it is going to depend upon Qn. So it's a kind of a loop, right? So what you can do now, we can simply make some kind of assumption, right? Assumption is something like Qn equal to 0. When Qn equal to 0, what might be the Qn bar? 1. If it is going to be done, then I can say that it is perfect. Otherwise, I can say it is undefined, right? So I am trying to draw a characteristic table for this. So one is S, another one is R, another one is present state, and the next state will be Qn plus 1, right? SR will be the 0 0, and I am assuming that 0 as the Qn, we need to calculate the what is Qn plus 1, right? Before that, we will try to substitute these values. SR are 0 0, 0 0. When these are 0 0, here always 1, right? For the positive level, 1 you got. So 0 and 1 is 0, with naught is 1. Same case here also done. Right? Now to find out the Qn bar, what is the value at this particular point? Qn value is 0. 0 and 1 is 0. Its naught is 1. Meaning that first level it is satisfied. Right? Now this Qn bar input will be passed to here. Right? If it is passed, 1 and 1 is 1. Its complement is 0. Which means that is it working perfectly or not? At this point of time, it is working perfectly, right? Meaning that whatever input that you are going to pass, that you are getting as 0. Okay, now try to solve it for another case 0 0 and Qn is 1. Right? So when Qn is 1, you are expecting here as 0. Right? When you are expecting here as 0, what might be the value of here? Here it is 1. So green color you can check 1. Earlier it is 1. I mean the input of other gate is 1. Other input is 1. 1 and 1 is 1. Its complement is 0. Are you getting or not? Yes. But try to observe, it is working up to now. But if you are able to take here that input as 0 here, what is 1 and 0? 0. Complement is 1. Okay. Now try to give that input 1 here. 1 and 1 is 0. 0 will be coming here and so on. Is it working according to or not? Yes. Meaning that here you are going to get the value as 1. So can I say that this is latch state? It is latch state. Good. Right? So now try to observe for the remaining cases. For 0 1, Qn is 0. For the same 0 1, Qn is 1. So this will be okay. Try to solve, what will happen? So here S is 0, R is 1, right? This input is 1. 0 and 1 is 0, its complement is 1. Here 1 and 1 is 1, its complement is 0 now. I am assuming that Qn is 0. When Qn is 0, here you are going to get the 0. What is 0 and 0? 0. Its complement is 1. Is it working accordingly or not? Yes, it is working accordingly. 1 we got, right? Now the same 1 will be given input here. 1 and 1 is 1. Its complement is 0. Yes, 0 will be done and the same process is going to be repeated, which means that for the 0 Qn, the next input will be again, next state will be again a 0. Try to do it for another number, another case, that is 1. When it is 1, here you are going to get 1. What is 1 and 0? So when 1 it should be 0. What is 1 and 0? 0. 0 complement is 1, right? 1 and 0 is complement. So here you got 1, 1 and 0 is 0, its complement is 1. Its complement is 1, meaning that we are not getting as expected. So we can write like 1. We can write like 1, right? Now this 1 will be sent to here. If 1 and 1 is 1, its complement is 0, which means that they are satisfying or not. Yes. Now this 0 will comes here. 0 and 0 is 0, its complement is 1. 1. Are you going to get or not? Now try to give 1. 1 and 1 is 1, its complement is 0. 0 and 0, 0, its complement is 1. So after some point of time, is it working accordingly or not? So which means that here what you are getting, q1 plus 1 is 0 only. 0 only. So I can say that this is reset state. Reset state. Okay. Now try to take out for another case. Guys, if you have any doubts, you can ask me. So I am going to simply redrawing this one. Right now, I am assuming that S is 1, R is 0, S is 1, R is 0. What might be the present states? It may be a 0 or it may be a 1. So here now it will be 1 and this will be 0. When 1 and 1, your output will be 0 for NAND gate. When 0 and 1, output will be 1 for the NAND gate. 1 for the NAND gate. Now I am assuming that Qn is 0. Qn is 0. When you are going to expect Qn bar, this should be 1. It should be 1 as expected. So now check whether it is 1 getting or not. 0 you are going to get here. 0 and 1 is 0. Its complement is 1. We are getting expected. Right? Now this 1 will comes here. 0 and 1 is 0. Its complement is 1. But it is not getting. Right? So means that I am getting another value. Now try to give the another value as input here. 1 and 1 is 1. Its complement is 0. Its complement is 0. Now this 0 will be given here. 0 and 0, 0. Complement is 1. 1 will be given input. 1 and 1 is 1. Its complement is 0. Means that at the end we settled that 1 0 as output. Means that if you are going to get the present state as like output as 1, its complement is 0 satisfied. So it means that if I am going to give Qn as 0, at where it is stopping? 1. So I can say that this is 1. This is 1, right? So now try to check for another case. Here I am trying to take it as 1. If I am taking it as 1, it should be 1. It should be 1. 1 and 1 is 1. Its complement is 0. So working for first iteration itself, right? Now 0 coming here. 0 and 0, 0. Complement is 1. So in the first iteration itself it is working. So if Qn is 1, Qn plus 1 is what? 1. So can I say that it's a kind of a set mode? Yes, it's a kind of set mode. Now try to observe for the other cases. 1 1. When it is 1 1, 1 1, what might be the Qn values possible? The possible values of Qn are 1 is 0, another one is 1, right? So if I am going to pass 0 and 1 subsequently, right, try to observe here S value is 1, R value also 1. When S value is 1, R value is 1, what might be the NAND gate's output? Right, it is 1 1, 1 1 is 1 and its complement is 0, 1 1 complement is 0. Now our assumptions are like when Qn equal to 0, Qn bar should be 1, right? Is it working or not? Try to check. This 0 will come here. 0 and 0 is 0. Its complement is 1. Working, right? Now try to observe. If I pass this 1 here, 0 and 1 is 0. Its complement is 1. Changed. Right? Try to check for subsequent operations. 1 you are going to get here. 1 and 0 is 0. 0 complement is 1. But here we have given 1. We have to get here 0 actually. Okay, anyway, let us check for another case. 1 you got, 0 and 1 is not get is 1. 1 and 0 not get is, sorry, NAND get is again 1. Meaning that for all the cases you are going to get 1 and 1 only. Means, can I say that this is a kind of undefined state? This is a kind of undefined state, right? So this entire table I can call it as again a characteristic table. A characteristic table, right? Guys, if you are able to observe, is this table is equivalent to the SR latch of NOR gate? Yes or no? For the same thing, 0 0 you are getting the latch state, 0 1 you are getting the reset state, 1 0 you are getting the set state. All are matching. All are matching, right? Yes. Now, can you able to construct the circuit diagram for this? Yes or no? Yes. So try to find out characteristic equation first. So the characteristic equation is S or Qn you have to take, right? So this is 0 1 0 0 0 1 1 1 1 0. So for what values you got 1? 0 0 1 you got 1, 1 0 0 you got 1, 1 0 1 you got 1, and for this you got as don't cares. So now try to make it combine. You are going to get as S plus, sorry, it should be S. It should be S. Now if you are going to combine like this, you are going to get R bar Qn. So totally the next state you are going to simply define as S plus R bar Qn. S plus R bar Qn, right? Now what about the excitation table? Right, you can able to draw its circuit diagram, right? Excitation table contains the outputs first, right? Outputs are like Qn and Qn plus 1. We can able to simply define what are its S and R, meaning that what are its inputs possible, right? Try to define. So we did it already. So for 0 0 what you have to do? For 0 1, for 1 0, for 1 1 what you have to do? When 0 0 is there, you are going to have two kind of possibilities are there. For that, one is 0 0, another one is 0 1. So I can write as simply 0 don't care, right? Similarly for 0 1, you are going to get 1 0 1 0. For 1 0, you are going to get 0 1. Very good. And for 1 1, you are going to mention like this one and these two. You can able to define it as 0 0 1 0. I can it as don't care and 0. This is the excitation table. Similarly, what is meant by function table? Right? So representing output in the form of input variables. Right? So you are going to have S R and Qn plus 1 terms. Now try to observe what might be happen, right? If it is 0 0, if it is 0 1, 1 0, 1 1. For 0 0, how it is acting? It is acting as like Qn only. For 0 1, it is acting like 0. For 1 0, it is acting like set mode. For 1 1, it is acting like undefined mode. This is the respective function table, right? So this is the way your SR latch is going to be work with respect to the NAND gate, right? So we can stop here, we will continue in the next class.